Imagine a time when life didn't exist. No plants, animals, or even microbes. Now picture how, from the chaos of the early Earth, life could emerge from nothing. Sounds impossible? Today, we're diving into one of the greatest mysteries of science, how life began from simple molecules through a process called abiogenesis. Stay tuned as we unravel how life itself could have sparked out of the most unlikely conditions. How did life begin? Was it a divine act, or did life arise from the simplest of building blocks through natural processes? Today, we dive into the fascinating and mysterious world of abiogenesis, the origin of life from non-living matter. Billions of years ago, Earth was a very different place. A volatile planet, bombarded by asteroids and surrounded by a dense, toxic atmosphere. The surface was shaped by violent volcanic eruptions, and the air was filled with methane, ammonia, and carbon dioxide. But in this chaos, something extraordinary happened. Life, in its most basic form, began to emerge from these harsh conditions. In the 1950s, scientists Stanley Miller and Harold Urey conducted a groundbreaking experiment, recreating the conditions of early Earth in a laboratory. They exposed a mixture of gases, methane, ammonia, hydrogen, and water vapor, to electric sparks, simulating lightning. After running the experiment for a week, they found that amino acids, the building blocks of proteins, had formed. This was a key moment in understanding how life's essential molecules could arise naturally from simpler compounds. But amino acids are just the beginning. Over millions of years, these simple organic molecules combined to form more complex compounds, proteins, lipids, and nucleic acids. The building blocks of life began to assemble. These molecules would eventually give rise to more sophisticated systems, capable of performing vital functions, like carrying genetic information and catalyzing chemical reactions. One of the most compelling theories about the origin of life is the RNA world hypothesis. It suggests that before DNA and proteins took center stage, life was based on RNA. Unlike DNA, RNA can both store genetic information and catalyze chemical reactions, making it a likely candidate for the first self-replicating molecule. The idea is that, over time, RNA molecules could have evolved to become more complex, eventually leading to the formation of the first true life forms. While RNA could carry genetic information, it needed a protected environment to thrive. This is where lipid molecules come into play. In water, lipids naturally form membranes, tiny bubble-like structures called protocells. These membranes could contain RNA and other molecules, creating the first primitive cell-like structures. These protocells were the stepping stones to the first living organisms, with the ability to maintain an internal environment and carry out basic biochemical reactions. Over time, these protocells evolved. The first self-replicating molecules passed on their genetic information to future generations. Metabolism, a system of chemical reactions that provides energy to sustain life, began to emerge. Through a process of natural selection, these early life forms adapted to their environment, becoming more complex and eventually leading to the development of the first true cells. Though we've uncovered a lot about how life could have originated from non-living matter, we still don't have all the answers. How did the first self-replicating molecules form? What were the exact conditions that allowed life to begin? Scientists continue to study abiogenesis, and while we may not have a complete picture yet, the possibility that life can arise naturally from the right conditions remains one of the most exciting mysteries in science. As we search for life beyond Earth, understanding how life began here is crucial. If life could emerge from the simplest of molecules on our own planet, who's to say it couldn't happen elsewhere in the vast expanse of the universe? The story of abiogenesis isn't just the story of life on Earth. It's the story of life's potential, reaching out across the cosmos. If you enjoyed learning about the origins of life, be sure to like, comment, and subscribe for more fascinating content. Share this video with anyone curious about the mysteries of life and let us know your thoughts. Could life exist somewhere else in the universe? We'd love to hear your ideas.